All right, this is the second page of your notes, and we just keep going. So this guy, Ben Franklin, we should all be really familiar with. He's our first American on here. And you've all probably seen that video with the little, it was a cartoon, and there's this little mouse, and he's helping Ben Franklin find stuff out about electricity and all that kind of stuff. Maybe you have, maybe you haven't. But Ben Franklin is known in chemistry for his electricity. He did really simple stuff, just kind of what is electricity, what's it do, and pretty simply, he obviously said that you can have a positive or a negative charge, and that those were the only two combinations you could have. And then he said if you're alike, you're going to repel each other, so you're going to try and get as far away from each other as possible, and that opposite charges attract. So again, not to insult you, it's just that's what he said. And then down here, you don't have to write it down if you don't want to, because I think you all know this, but positive and positive are like charges, so they're going to repel, and so on and so forth. And the only ones that are going to attract are the positive to negative, and that's kind of what he's famous for. The next guy, Michael Faraday, is even shorter. If you take physics, he's a big guy. He did a lot. He actually has his own unit called the Faraday. And what he did was he did more than this. But for chemistry, all you have to know is that he said that there's something about the atom that's going to be related to the electricity. So at this point, remember, we still don't know about electrons, protons, neutrons, any of that stuff. It's still back in the 1800s. So that was his big contribution. He went on to do more with physics, but all we have to worry about is that he did hypothesize that. All right, the next big guy, and we're just going to do Crookes and then Wilhelm Röntgen for today, is Sir William Crookes. And he's basically known for making something that's an experimental thing called Crookes tube. And they use this Crookes tube for basically most of the rest of the history. So what he did was he took this, a glass tube, and basically evacuated most of the gas out so that it was at a real low pressure. And then what he did was he actually started to run electricity through it. And when you have electricity, you have to have a place for the electricity to go. So he had a cathode, which is negative, and it was just a piece of metal that was negatively charged. And then he also had an anode that was positively charged. And again, it's just another piece of metal. And what they did is they would run electrical current through it, and they actually would see this weird little, it was a ray. And what they saw was that the ray was coming from the cathode, so they called it the cathode ray. And this is kind of a big thing. They didn't know what it was, and it's kind of a turning point for what's going on with atoms, in regards to atoms. All right, so next one, this is Michael Faraday. Remember, all he said was about the electricity, that there was electricity, that kind of stuff. And then this is Crookes, who made his Crookes tube, which they also called a cathode ray tube. You can say either or, it doesn't matter. All right, so this is kind of a really bad diagram of a Crookes tube. But up top here, if you're in physics, these lines here mean that there's some sort of battery or some sort of electricity. So they did have to have a form of electricity going through this. And then the black kind of just lines right here just show you that these are wires. So this is just showing there's wires connected. And then what we have here is we have the first little thing that's our cathode. And you just want to remember that cathodes are minus. So I would draw a little minus on your dot and make sure that it's coming from the cathode. And again, the cathode's just a piece of metal. And then over here on the other side, we have something very similar to the cathode, but it's an anode, and that means it's going to be positive. And then keep in mind that there is a gas inside there. There is something in there, but it's going to be at a really low pressure. It's not really going to affect us or anything. And then when they turned it on, when they turned on the electricity, they got this green glow that traveled from the cathode to the anode, and they called it a cathode ray. And again, we don't really know what it is at this point, but this is what they're studying. So you don't have to write a lot of stuff down. You don't have to worry about combined study of matter and electricity, stuff like that. You should know there is an electric current being passed through it, but since there's electricity right here, you should know that. So what they did, though, down here, is they decided to start playing with the cathode ray. So what they did is they started holding up magnets and they would hold the negative side of a magnet up. And what happened was when they held the negative magnet up, the cathode ray would actually move away from it. It would repel from it. So if we just think back to what Benjamin Franklin said, is if we hold something negative up to it and it repels, that means that cathode rays have to be negative. And I would write that down. Cathode rays are negative because they repel from other negative things. And the same goes if they put positive towards it, then the cathode ray would be drawn towards the positive. So they figured out that, okay, we don't know what it is, but we know it's negative. And then another thing they did is they would take a little tiny paddle wheel, sort of if you think of like a paddle boat, one of those things, and they would actually put it in, and I'm going to try and draw this not very well, like it's like a little X, and they would actually put it in the inside with the cathode ray, and what they saw is that the cathode ray would actually start moving the paddle down. And again, this is not a very good drawing, but they would actually start moving the little paddle wheel down. So the other thing you want to know is that the cathode ray has to have mass, because it's not just pure energy. It's actually able to move a physical object. So again, they ran electricity through this gas. You just want to know that it was running through. There was a cathode and an anode. And then what they found was that the cathode rays are negative, again, because of that repulsion thing that Ben Franklin talked about, and that they also had mass. This was a huge thing. No one had heard about it before, and it was a big deal in science. And what they started to decide to say is, okay, what does that mean for atoms? Where is this electricity? Like, what's it mean for everything? And it's really going to change what they thought of the atoms. And again, this is all because they got all this new technology. They have electricity now. So it was really changing what science was doing. All right, and then the very last guy we're going to talk about today is Wilhelm Röntgen, which sounds like an interesting name. He's German, and from basically here on out, we're going to use the Crookes tube, or again, we can call it a cathode ray tube. It doesn't matter, but we're going to use that for every experiment. So he used a Crookes tube. He had the gas in there, and what he saw was that he was a photographer. And he had, back then, remember, there's big photographic plates, and they had to like be underneath a big blanket when they were taking people's pictures. And what he kept having was when he was using the Crookes tube, his photographic plates would keep getting ruined, and he didn't know why. And what he figured out was that there was actually these rays coming out of the Crookes tube that he couldn't see. And it was ruining his photographic plates, and it was kind of like, it was actually, if you see here, fluorescing some of the glass, and it was just kind of messing with things. So what he said was, I have no idea what they are, so he called them X-rays. And he actually won a Nobel Prize for it. And this is a picture of him, Wilhelm Röntgen down here, and then this is a picture of the very first X-ray he ever took, and this is actually his wife's hand, and she doesn't have some horrible thing right here. This is her wedding band. Really big ring back then. That was kind of fashionable. So she wasn't weird. She didn't have some growth or something on her fingers. All right, so hopefully you have good old Wilhelm Röntgen, and you want to definitely know the Crookes tube because those are the kind of the big things from today.